Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Interplanetary Climate Change. Planet X Causes Solar Flares. Now, solar flare is an intense flash of light from the sun, which is accompanied by the emission of very fast-moving protons. The light emitted is in all ranges, from radio to gamma radiation, but seems to be most intense in the extreme ultraviolet and X-ray ranges. So the sun is usually monitored in the X-ray range for the occurrence of such events. And here we see an image showing one of these solar flares. You can see part of the sun from which the solar flare comes from becomes extremely bright. And we also have protons produced at that time. Now, why do solar flares occur? As solar physicists, using accepted theory and denying the role of electric fields and the presence of stellar cores in the solar system, would simply say that it just happens, or the sun goes through cycles, and when it becomes more active, solar flares are likely to occur. This is the answer of someone who does not understand how the sun or the universe really works. When there is true understanding of how something works, then the cause behind what that something does is always understood. The sun does not have effects without causes. If solar physicists really understood how the sun worked, they would not talk about cycles and probabilities. They would be able to explain why the sun is more active or less active at any one moment, and they would be able to explain why a solar flare occurred. Thus, good theory is able to explain the true cause behind any effect, and bad theory cannot. Now, through observing stellar cores in the sun's corona and noticing how they absorb energy from the sun, I have come up with a theory called electro-gravity, which attempts to explain the mechanism behind solar flares and the reason why they occur. Stellar cores are very much involved in that. And you can see a stellar core here. We can see it's a dark object, obviously spherical, within the sun's corona and making a plasma connection with the sun. So this is one of the stellar cores that are observed in the sun's corona. And we have another one here. We have this circular outline, which indicates there's one there. This one, though, has gained coronal plasma as an atmosphere and is now able to emit light. So this one is more likely a newer arrival. Now, solar flares occur because of outside influence on the sun's atmosphere or surface. The sun's atmosphere is made of plasma in arc mode, so the light emission is an electric effect. It is as if the sun is in intense lightning mode all the time. In this mode, particles are moving at high speed and photons are constantly being interchanged. Some particles give off photons and some particles absorb photons, but huge numbers of photons also manage to leave the sun. And these are detected on Earth as having come from the sun, which is why the sun looks bright to us. When a stellar core comes near to the sun, it draws a current of electrons from the sun. Electrons are accelerated, which increases the electric field at the point where the current is leaving the sun. The accelerated electrons release photon energy from within them in the form of free photons. If the released photons have high enough energy, at least 940 MeV, and the electric field in the environment is high enough, protons and electrons emerge from within the photons. The electrons are retained and the protons are ejected into space at high speed. The greater the electric field, the more intense will the radiation emitted be, and the faster will the ejected protons move. And you may look at Article 196 entitled Stellar Cores, Particle Mass, and Replicator Technology. And this image illustrates what the stellar cores cores to happen. The stellar cores have this effect on the sun because the stellar cores are low in energy and the sun still has a lot of energy. So as the stellar cores come close to the sun and make contact with the sun and they make a plasma connection with the sun, energy starts flowing from the sun because the sun is like a hot object now in contact with a cold object. So energy flows from the sun out through the connection towards the stellar core. And this means that the surface of the sun will get hotter or more energetic, and thus more radiation and more particles will come from that region. This is why the sun's surface at that point will then become more active. And more energy also flows even through the plasma, making the connection between the two, which makes this connection also more likely to emit radiation. And solar flares can also more likely occur at this point where this connection is being made. And then you can also have a coronal mass ejection, which is large amounts of coronal plasma being ejected out from this region, plus the connection itself, and then the stellar core moves out with it too. And what occurs in the sun's atmosphere in that photons actually become two particles. So photons actually carry particles within them. And when the photon moves through a region of high enough electric field, these particles emerge from within the photon. The photon energy then goes into producing the mass of the particles, and the rest of the photon becomes energy within the particles. So this is illustrated here, how acceleration of electrons, how this electric discharges cause photons to emerge from within these particles that are accelerated. And if the field is high enough, which is represented by this blue arrow, then particles, protons and electrons emerge from within photon. Now, the reason why electrons are retained is because the gravitational part of electrogravity causes electrons to be attracted to electrons in the sun's atmosphere. But the protons are repelled. The greater the photon energy inside the protons and the electrons, the stronger the repelling force. Thus, a stronger electric field will lead to more photons being emitted, which means the light will be more intense, and protons to end up with more photon energy inside them, which will then cause them to move at speeds very close to the speed of light, because the repelling force between them and the sun's corona will be stronger, so they will be accelerated to higher speeds. Now, electrogravity is the theory that I came up with to explain what is actually occurring and what's causing coronal mass ejections to be repelled and the stellar cores to be ejected at the same time. And this is illustrated by these two diagrams here. And this is because electrogravity combines two interactions, the electrostatic and the true gravitational interaction, which is a lot like the electrostatic interaction, but it always opposes the electrostatic interaction. So where we have attraction of a proton and electron in the electrostatic interaction, you're going to get the opposite, which is a repulsion. In other words, the proton and the electron will tend to move apart. So, and the electrostatic interaction is of equal strength in all cases. That's because it does not depend on the photon energy within the particles. But the gravitational interaction does depend on the photon energy within the particles. So this repelling force between a proton and electron, for instance, will become stronger if there is more photon energy within the two particles than if there is less. And it is this asymmetry between the two interactions, which allows the universe to have the observed structure where all objects from atoms to galactic nuclei have a dense proton-rich and positively charged interior. So in the case of the atom, that would be the nucleus that has a lot of protons in it, so it's rich in protons, and a negative outer layer which is made up of electrons. The atom has electrons in a region outside the nucleus. But celestial objects have the same structure. They have a dense core that's rich in protons, and they have an outer negative layer which is rich in electrons. There will be some protons in it as well, but it's mainly made out of electrons. And this is explained in Article 181 entitled Stellar Cores and Deciphering Gravity, where I detailed how I came about these ideas regarding gravity. And in Article 182, I actually explain how the theory works in detail. And that article is entitled Einstein's Dream Realized, Unified Field Theory of Electrogravitation. Now, it isn't just stellar cores which are able to provoke the sun into having solar flares. Comets also cause the sun to have solar flares because they too draw a current of electrons from the sun's corona, as James McCanney has explained in his book Planet X, Comets, and Earth Changes. In addition, coronal mass ejections usually occur in association with solar flares. And the comets seem actually to cause these coronal mass ejections more than solar flares. They are solar flares. They're usually weaker than what the stellar cores seem to be able to get the sun to do. Now, coronal mass ejections are the ejection of large amounts of coronal matter. This seems to occur as a result of an increase in photon energy in the region. As electrons move through the region, more photon energy flows into particles in the same region, which strengthens the gravitational repulsion between protons and electrons, and thus leads to a large amount of coronal plasma containing mainly protons and ions to be ejected from that region of the corona out into space. Stellar cores do not seem to be able to draw a current from the sun until they reach the sun's outer or inner corona, and this seems to be due to their very low energy state, which decreases the distance at which they can draw energy from another object. Now, the Carrington event of 1859 seemed to be the first time that a solar flare event was observed by an astronomer. On September 1st, 1859, Richard Carrington was looking at sunspots, which his telescope projected onto a piece of paper. He had noticed that a huge number of sunspots had appeared on the sun several weeks before, and now as he looked at them, he saw blinding light being reflected off the paper over a time span of about 5 minutes. He was observing a solar flare, although he was seeing only the visible light emission part of the solar flare. Since the first appearance of noctilucent clouds in 1850 suggests that the stellar core system reached the inner solar system at that time, the Carrington event was most likely caused by one of the larger of these objects arriving at the sun's corona and starting the process of drawing energy from the sun, which resulted in the intense solar flare. Noctilucent clouds will be produced from dust or small stellar core matter entering the Earth's atmosphere. However, a solar flare or CME from the sun is more likely to be caused by the larger objects. The smaller objects will also draw energy from the sun, but it will not be as a result it will not result in such an intense electric field being generated at the point of contact. And here you see a photograph showing noctilucent clouds, which were first observed in 1850, suggesting that that's when stellar core dust or the stellar core system started invading the solar system. And you may look at Article 275 entitled Planet X Debris Field Impacting Earth. for more details. Now, the largest solar flares seem to have started in 1989. They seem to be well, here there's one from 1978, but this was not actually a solar flare. It was just a geomagnetic storm that was observed on Earth. No solar flare erupted from the sun at that time. Some weaker ones were started being observed in 1982, as you can see here. Now, the largest solar flare started occurring, as I said, in 1989, and we do have smaller ones from 1982. The size of the solar flare is likely to be associated with the size of the stellar core as it first arrives at the sun's corona. They would draw more current when they first arrive, as they are at their most depleted then. Also, the larger the stellar core, the more current it is likely to draw when it makes contact with the sun at the sun's corona. The fact that an extremely large solar flare, X20, occurred in 1989 suggests that one of the largest ones arrived at the sun's corona then. The 1978 event, as I said, was not due to a solar flare, because no solar flare was observed erupting from the sun at that time. In conclusion, solar flares on the sun are the result of objects inside the solar system drawing an electron current from the sun. The stellar core's presence in the sun's corona leads to the sun reacting with solar flare events and coronal mass ejections, and electrogravity can be used to explain the mechanism behind these events. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.